how they strategize on CDNs and multi-CDNs.
No CDN will be perfect all the time in every location.
Dynamics of this country is so different from the dynamics of any other country. The toss is the first point where we get a signal of how big this game is likely to be.
Hello everyone, welcome to the second episode of this ongoing series where we are covering end-to-end workflow for a large live event. The previous episode we concluded on content preparation. For this one, we would like to discuss content distribution, where CDNs play a large role. Welcome back Nikhil, Ashutosh and Will. We'll get to the first topic in this discussion, which is primarily reverse proxies or these giant proxies which are CDNs. Now, most viewers connected to this stream may already be aware of this technology, but I'll briefly introduce it. These are giant proxies that have nodes across the globe that help us scale and deliver some of these large events and other type of content as well. Now, with the live streaming that we are seeing today, what we've seen is the bit-heavy content has increased. The screens that we have today are a lot better than what we had. The compute we have on our devices, we have 4G, we have 5G, that at least in our country, the coverage is really good right now. And then you have all of these fans, there's a shift to OTT because of all the engagement and other additional features that come along. It's a feature-rich experience. With that, you have 10s and 20s and 30s and 40s, and that continues to go on, millions of viewers that all watch this stream at the same time. And while Akamai pioneered the content delivery space, we've also continued to innovate with edge computing capabilities. Well, we're seeing a lot more multi-CDN today with bit-heavy or video content. And that has become much more of a reality because I don't think there's one giant proxy that can service all the bits that are needed to stream something like a Tata IPL in India. So then it becomes a multi-CDN strategy. But what we've also seen is while you may have the strategy that sticks for bit-heavy video and audio files, you may not have the same strategy across the board for your web content, your images, your APIs. So there are different types of content that eventually get you to play the video. What are you seeing globally before I give it to Nikhil and Ashutosh on how they strategize on CDNs and multi-CDNs?
The reality is that servers fail, right? They fail and we can't stop them failing. So it's interesting. You got to build a business on things that don't work all the time. So Akamai builds a delivery service by having hundreds of thousands of servers, some of which are always failing, but having smart logic to figure out how to route traffic around them and how to provide a consistent service on the outside. So that's how we achieve reliability. We expect failure, we plan for it, and we have redundancy. So that same approach is used for CDNs as a content distributor. No CDN will be perfect all the time in every location, everywhere for all devices. Even Akamai. We try our hardest, but it's not going to happen, right? So you can get a second CDN and a third CDN. The question is, how far do you go with that? So if we look famously at Disney, at one point they had 8 CDNs for distribution. They have since pared that down to 2. And why is that? Because every CDN you add is a lot of additional overhead. You have to sign new contracts. You have to distribute new content. You have to create new tokens for access. And more importantly, you have to ensure feature parity in what the CDNs can do. Like Akamai can do watermarking at the edge, right? But if you have 8 CDNs, you are very quickly driven down to lowest common denominator features. And that's not good for your business. So my recommendation, I think multi-CDN makes sense. If I was CTO of a company, I would use more than one CDN, but I'd probably go to 2. I think having 2 CDNs that have the features you want is manageable and gives you a high degree of redundancy. And your marginal benefit as you go to more CDNs after that is going to decrease very rapidly.
I think the way the multi-CDN strategy works is, while you're right about the least common denominator thing, right? Because you are always like limited by what this thing. It's also a function of what our business needs are, right? In our case, I don't think just 2 would work with the kind of scale and the kind of events we do, right? Sometimes maybe for VOD, but not for live.
Yeah, no, I think for us it was a far more complex, kind of decision. I think the first big factor was, where do our consumers come from, right? Particularly when you're serving predominantly mobile customers, the carriers become important, right? And CDN presence in the carrier network, right, which is first hop from the carrier's network, becomes even more critical. So we started to kind of learn more about this distribution, right, and what is the presence of each CDN in each of the key carriers that consumers are connecting through. So that's one big factor. The second big factor, where is the demand coming from for this content, right? But IPL is also very diverse because we publish it in as many as 12 languages, right? And India is a very diverse country. Linguistically speaking, we have 25 to 28 official languages in the country, and we stream in 12 languages every season of IPL, right? And each of these languages has their own regional markets or demand patterns. So last year we experimented with a new language, which was Odia, which had never been done, right? And that unlocked a new market, a new audience for us, because for them that was their native language, and it was an amazing experience to have Odia or Haryanvi or Gujarati as new languages of sports commentary. It makes that more relatable. That experience is far better for them. And that meant that there's a huge influx of new users who might not have watched IPL before, but now they're watching it because it's available in their language, right? Their preferred language. So that is another big factor because that introduces new demand, right? So this year we did Haryanvi, for example, right? We did Bhojpuri last year and we continued this year as well. Last year, Bhojpuri incidentally became the third largest language by concurrency, right? Which is a very big deal. And year one, you have so much new market being developed. So that's another big important factor. I think the third one is that we realized the scale of IPL is such that we needed something like about 75 TBPS of capacity, right? And I don't think there's any single CDN which has that kind of capacity, in any one geography. In IPL, we are talking about one geography, and that capacity is fairly large to aggregate. So it is not about 1, 2, it is about aggregating everything. So that's a humongous amount of capacity that we need to provision because we are sizing for what we think is going to be the largest peak audience that we'll see. The season opening game and then the playoffs and the final game typically see the highest concurrencies. But we also have some games which are among the top 3 or 4 teams. Whenever they're playing each other, we see very high concurrencies. We're trending towards something like 25 million concurrency being the new normal, right? And then you have these surges which go beyond this, right? So to plan for those surges, we need to have all capacity available throughout for serving each carrier network, serving each regional, geographical region of demand, and then serving for all of the scale and surges, right? So those are the 3 key factors which determine how many CDNs do we need to use to serve the user.
I think there's another factor is just as you was mentioning the pairing and presence in the carrier. It's also what kind of traffic are you sending to the CDN, like choosing the CDN. You notice that sometimes things work better on broadband, for example, right? Like if you're serving TV traffic, those networks are more stable. There's less of movement in upshifts and downshifts, and there's less variability, right? Like connected TVs have a less variable movement and all of that. With mobile, that becomes interesting and tricky, right? That's where what Will was saying, that how does the resiliency bit becomes important, right? As the traffic is shifting, as the users are coming, and I think the key peak time at which the CDN's resiliency gets tested is when the innings start.
Yeah.
In the first 5 minutes, when the traffic ramps from just 0 to like 80% of the peak or the thing within a short period of 5 minutes, that's where you test all your systems and everything, right? That's a breaking point. If anything can survive that.
I think we have these points that we watch out for. So typically when the pre-match show starts, we know that that's going to be like just very basic level of traffic, very low concurrencies. But the toss is the first point where we get a signal of how big this game is likely to be, right? Because that we know what teams are going to play today, right? And the toss determines who's going to bat first. So by the time the toss happens and the result of the toss, we know which inning is going to have the higher concurrency of the two, right? So we know which 2 hours to focus on and which 2 hours to we are comfortable in, right? So that's one. Then you have the first ball being bowled, right? Because a lot of people will queue in. The toss happens about 25 minutes before game start. And then that first ball being bowled is another waypoint where we see, okay, what was the concurrency at toss? Then what is the concurrency at the first ball? And then the first power play, which is the end of the first 6 overs. So that's likely the zone where we'll have high concurrency. And then towards the end of the game, the last power play or the last few overs of the second inning, right? So those are the key points. But then, like you just mentioned, there's Dhoni coming into bat. That is an independent big event by itself.
Yes. Yeah. Just to add, like while Nick was saying that who would choose to bat first, right? I think it's important. So sports is designed to start at 7:30 so that it closes off in around the 9 to 10, 9 to 11 kind of a zone, which is the peak viewing time, prime time of the content, right? So and it's important because at that point people are consuming other things on the internet also. So if the team which is gonna bring in more concurrency gets to bat first, then probably the end of the innings is gonna coincide with that 9 to 10 p.m. peak, and that's where your capacity becomes very interesting because you have other neighbors also, right? I think you must have seen that, like if the same thing used to happen at like later in the night, probably will be able to get more capacity, and it's a variable, right? The capacities are not always static as people think. If you want to add something on that.
Capacity planning for sports events is one of the biggest problems for a CDN because it's this instantaneous terabits a second of demand arrive within a minute or two on a network. But we're not magicians, right? We're engineers. So where do we get this capacity from? And the answer is we have to reserve it. We have to have that capacity sitting there idle right before that decision is made and that peak comes. Otherwise, we can't serve it. And that means we have to keep traffic off of some machines in anticipation of a high peak arriving. And that's part of the event planning that was discussed in the first series. I want to make one other comment about architecture because I don't think people appreciate this about Akamai. We're quite different to other CDNs. Other CDNs put servers out there and they might have 10 or 20 or even 100 POPs, right? Points of presence where their servers are located and they serve out. Akamai, from the very beginning, is highly distributed. We have over 4,100 POPs in different networks. And it's very expensive for us to put all these servers out there. It'd be much cheaper to put them in fewer POPs. But we do it because we avoid a lot of the peering congestion. We serve what is called on-net traffic, right? We serve in your ISP to you in your house. And that means that ISP doesn't have to peer out through other autonomous systems and get back to the origin. And that's where a lot of the congestion occurs, especially at peak time, and especially when who bats first decisions are being made.
Yeah, I think this is a very important point. I have had meetings with the CTOs of different mobile networks as a part of the pre-planning Tata IPL capacity, right? And everybody's concerned about their backhaul links and, what's going to be the impact of the game start and huge concurrency events. Very recently, I had one very interesting case where a carrier came to us and said, I am Tata IPL has, thrown my entire capacity planning out of whack for one particular region, right? This is an offshore location, so it's an island. And usual traffic over there and their backhaul from that location to the mainland was a certain capacity, let's say, 10 gigabits. Usual traffic pattern was about 5 gigabits worth at peak every day. And now suddenly when IPL started, right, day one, it got completely swamped, right? So they reached out to us to see how we could help them, and contain this surge, right? So these are the kind of things which we hear and we think about as to how we can improve this, because it's affecting not just our planning and our infrastructure, but the entire infrastructure.
It can cause denial of services on the rest of the
It's a very significantly large truck going along that road, which the road is not going to get wider. The truck is huge.
Very interesting with the last mile impact that
Mile, absolutely, the big truck.
Yeah, because that in fact brings us to the next topic, which is edge computing capabilities. Now, Akamai has been doing this for over 20 years. We not just pioneered CDNs, we not just became a global leader there, but we used a lot of edge computing capabilities to build a lot of products for ourselves. We could do API capabilities with security, we could do image optimization, a lot of other capabilities where we tend to differentiate ourselves from a lot of other proxies out there. Not just the way we scale and distribute across ISPs, but also the other capabilities that lay on top of the platform. Using some of these workers to offload some of your logics to the edge. And is there merit in it for you as a platform? And if there is, then what are the key use cases or some use cases that you may want to begin offloading to the edge?
Yeah, I think there's a lot of use cases. We actually spent some time last year thinking about what could be the potential use cases for offloading to the edges. And then there's, I think, something in the entitlement space, definitely something in the security space. There are multiple use cases beyond that as well, which are more fancier implementations, which are nice to have, not yet essential. But I think security and monetization are the top two, which could result into really good efficiencies, right? Or better security. But Ashu should talk about that.
Yeah.
These are things that he's been planning for.
I think the question of edge compute, see, one of the things is that in India, the data centers presence have increased, right? Like the larger data centers. The reason I would go to an edge compute would be if I have to reduce latency. That's one of the reasons, right? I do not want like even the request to even come to my data centers. But that has also improved given the network conditions have improved, backbone connectivity have improved. So then the question is, why should I go to edge compute? One is I want to reduce chattiness with my, like I need a more chatty client and server interaction, right? So that's where I would say that, okay, let the, one of the ideas is like low-end devices. Can the edge compute do more work for, like rather than doing the device, because as we spoke earlier, right, that the device computation is limited. Can I make decisions on behalf of the device on the edges, right? Those are the kind of workloads we keep on thinking that whether we can bring it to them. Monetization is another important, like you're streaming videos, right? Which ad to insert, how to insert the ad, that is something for which I do not want to go to the origin, because then I have to, like the entire bit has to be transmitted from a large, like a distance place to this thing. So can I use things like that over there? Over there is what I believe edge compute makes sense, or if you have a latency concerns. I don't think otherwise it's complex to leverage edge compute in a scale. Theoretically, it makes perfect sense, but when it comes to scale, I think it becomes a little tricky to deploy and use, is my sense.
Yeah, I mean, there are so many factors which come into play, right? If you are building anything which requires state to be managed, right, then you have identity which comes along with it, right? And then saying, okay, how do I know what state should this be in, right? And if that user moves between the edges, mobile users, then what happens? So it adds that whole layer of complexity to this. But, I could think of reducing some latency on streaming by simply moving some encoding operations, right, to the edge, if that were possible. But edge compute is not today equipped to do that scale of compute, right? I think that's where that whole maturity curve is still to kind of set in, where what you can do is light decisions, stateless decisions. We could do some form of manifest modifications or some kind of manifest filtering on the edge. But that's very light work. It's not yet really at that evolved state where you can treat each edge as a compute origin, right? That's not happening yet. So, but I think we're going to reach that point where centralized, application origins, right, for APIs and other services are going to get constrained. Today, that is already happening for media origins, right? And you need to think about multi-origin distribution. So similarly, application space also will start to feel that pinch as each of these services need more and more infrastructure if they remain centralized. But if they get decentralized, then it might be useful. But I don't think we're there just yet.
You bring up a good point where they still tend to remain mostly lightweight. While most platforms these days are trying to make it stateful, they're still lightweight and it's light databases at the edge. So
I think I'll ask Will this, right? Like when you think about computes on the edge and all of that, right? Like typically proxies are designed to be not compute intensive. They're designed to just handle the connection and then hand it over there. Like you're reading files or you're reading streams of data which is being transmitted. Now bringing in compute to the edge, it adds a lot of complexity from a CDN point of view, right? So how do you think about that?
It does add complexity. Akamai didn't, we had built-in compute to our servers, but we've introduced now far more flexible edge compute. And it's in different layers, right? There's what's called serverless edge compute, which is where you put JavaScript or WASM up at the edge, and it's performing functions. And then you have another level of compute where you're running Kubernetes, managed Kubernetes, or containers. All of those are in this bucket of edge compute. Edge compute is a lot like Miami real estate. If you've ever tried to buy an apartment in Miami, I haven't. But if you want to buy it on the beach, it's $3 million. And if you go 2 kilometers inland, the same apartment is $1 million. And why? Well, it's because beach real estate is highly desirable. You have to want to be there. It's the same for edge compute. It's more expensive to put all these servers right at the edge. So why do your compute job there? And I think there's two reasons. The first, as already mentioned, low RTT. If you're doing something that you have to do very, very quickly, this is the closest place to do it. Okay? There's a lot of jobs that aren't low RTT, like transcoding VOD files. You should never do that at the edge. Doesn't care about RTT. The second reason to be at the edge is the edge server is seeing the individual connection from the end user and can thereby personalize it. And the personalization of responses is becoming critical in media. So when we look at personalization, it's the media we deliver is essentially a text file followed by a bunch of media. And text files are this lightweight operation that Nikhil mentioned. It's very easy for us to modify them at the edge. And it's also very useful. So we can trim the bit rates. You can have one manifest that's got all your bit rates, and right at the edge, as you deliver it, you can turn it into a mobile one or one for the home while just caching the one object. So that's very useful. You can localize the language. You can strip out the 27 languages that you don't need and just leave the one in that you do. You can add bumpers, you can add watermarking, and most importantly, you can do personalized monetization, which would be server-side ads. Those are all very valid reasons to do this lightweight compute at the edge.
Before we conclude this episode, and this is probably the most interesting topic that I have in this episode, maybe even going back to the previous one, which is all the new technologies. So there's so many new technologies that have come up over the last few years. There's media over QUIC, there's low latency specifications for HLS and Dash, there is HESP or HESP. You have all the 4K and Dolby in picture. So all of these new technologies, in fact, there's one customer that we were recently onboarding, and they've built an application called Decoder, which is entirely built on AI capability. So AI captioning, a lot of these features, that's what they're trying to get to in the market right from their launch. Now, I know you do a lot of AI capabilities in your systems as well. And Will, you tested a lot of these technologies, the low latency specifications. And I know you've been spending a lot of time on media over QUIC recently. And you are pretty well aware and you've looked into HESP. So I don't know if you want to add your thoughts on what sort of adoption are we seeing, and then also maybe add in content steering to that?
Yeah, so there's so many subjects there, it'll be an hour. But let me try to just summarize some of the ones that I think are most interesting that have arrived in the last year or that will arrive in the next 2 years and that are going to change the landscape that we're talking about. So CMCD, Common Media Client Data, is a very simple way where a player, as it's requesting media objects, transfers some information about its health, what buffer it has, what's the size of the media object. It goes to the CDN logs, the CDN can make use of it to react to player problems, because otherwise we're blind as a CDN. And more importantly, the distributor can collect that information in real time. So it's all about observability. It's become widespread. Just about every player supports CMCD today, except for the AV Player AV Foundation. And that itself, I hope, is going to be rectified pretty shortly. So we have this new data coming in from players that we didn't have 2 years ago. And we're working on CMCD V2 at the moment. So it's going to have even more information and provide an ability to beacon data at an interval to a third-party collector. Content steering is the ability you give your player multiple locations or CDNs that can pull content from, but in the middle of the stream, you can steer it from one to the other. And you might do this for performance reasons, or you might do it for contractual volume reasons, or you might do it for content reasons. But the important part is there's now this authoritative steering server that can deterministically control a large cohort, millions of players, and get them to do the same thing at the same time. We've never had that type of control in live events before. It's new, but it's released for HLS and Dash as part of their specs, and we're starting to see solutions being built. And it becomes a single point of failure. If your steering server is not good, you can DDoS your whole live events. You have to be very careful about how you use it. But if you use it right, it's a powerful tool. We have another spec that's going to be released in the next 40 days or 30 days, fingers crossed. It's called Common Access Token. So another problem, we'll talk about multi-CDN, but you typically want access for these. These are granted by bearer tokens, and every CDN is a different way of constructing its bearer token. So it's one thing to say, I'm going to switch people to another CDN, but how do you give the player the right token to do that? So we identified this problem 2 years ago, and we've been working on a common access token, CAT, as we call it. And it's very simple. It's one token that works everywhere for all media content, but it's very flexible. You can gate or control access on time, on location, on geo, on type of connection. There's, I think, 18 different claims you can control. It's really feature rich, and it's going to come out in the next, the spec will come out in the next month. There's also a spec called streaming media tracing. So I think Viacom at 18 will be very well aware of this. When there's a problem in a player, right? The player says, oh, I blame the CDN. The CDN says, oh no, the origin didn't give me the data. All of which, you're very hard to tell where the problem resides. So streaming media tracing is the notion of, as the player requests something, we can track that request to the CDN, down through all the servers in the CDN, to the origin, and then back up again to make through maybe stepped CDNs to the player. And if everything's good, we throw this information away. We don't care about it. But if it's bad, now we have a breadcrumb trace or a record of exactly how that media object moved, and we can debug problems much quicker. This is another spec that's being worked on, will come out in the next year. Then the last one that Bilal mentioned is media over QUIC. This is something I'm working on at IETF. It is next generation streaming. It takes advantage of QUIC, the QUIC protocol, but it doesn't do it via HTTP3, which is how HLS or Dash might leverage it. It does it via web transport in QUIC. QUIC provides the ability for multiple parallel streams of data in conjunction with datagrams. So we're developing a pub-sub protocol for media distribution, publish, subscribe. So instead of a player asking for segments every 2 seconds and for a playlist, the player simply says, give me the 720p feed for the cricket game. And it's for the next 2 hours, it is sent the data. It doesn't have to make any more requests. Much like a multicast or broadcast. The difference is this is cacheable in a CDN, and the latency is tunable. So we can use latency from 300 milliseconds up to 30,000 milliseconds, which would be 30 seconds. So get used to cricket where you can see it well under 1 second. I think that's the target. Obviously, the challenge is doing it at scale for millions of people. That's going to take many, many years. But I think you'll start to see media over QUIC spec maybe being finished next year. But in the next 2 or 3 years, I think it's quite an exciting innovation that's coming out for OTT stream.
Ashu, would you like to add?
I think all of these technologies you spoke about, right? Some of these are fairly not new construct, right? If you talk to an engineer who's building APIs or backend systems, request tracing and data, passing out data, metadata from one service to another, this is fairly common. The key problem is adoption and availability. I think that's where this thing like this, some of the good specs have been there for a very long time. Unless they get adopted widely, they'll not add value to as a publisher or as a platform hosting content or this thing, right? Media over QUIC, which Will spoke about, that's UDP. I think I don't know how it will pan out at scale, to be honest. Theoretically, everything looks good. Lab-wise, it looks good. When you talk about mobile networks where there's congestions, users moving from one location to other location, you're not even constantly connected to the same server. You might be switching servers as you're streaming as well. Those things, it will become practically how these pans out would be very interesting to see.
No, I think all of these are very interesting, and some of them are very practical, right? CMCD is very important. We've already started implementing that. But this year we already have that support. It's going to get richer, right, in terms of the context that it provides to the layers in between the user and the origin. So that's going to be very critical. The most important one, which I think we have achieved, is cat. All these years of internet streaming, and we have never streamed cats. Those are the most popular, right? So we finally got our own cat to stream. But yeah, I agree with Will. All of these are going to change how we do streaming. We have to necessarily think very long timelines. We're not just thinking about this current year of streaming or next year. We know that we're going to be streaming this event for another 4 years or possibly a lot more than that. But when we do it for over these years, we're constantly looking for that next breakthrough, which gives us a little more sustainability of streaming, a little better experience, a little better quality for each user, and support across all the devices. So it's a bunch of trade-offs which we have to deal with, and I think that's what we end up doing most of the time. We see that this thing is emerging, but we have to wait for that to actually.
I think the other variable is Asia, in specific, like the population and the size of the country and the dynamics of it, how we operate. I think a lot of specs are written keeping in mind theories and some of those things. But when it comes to practical implementation, that's where I'm worried, because the dynamics of this country is so different from the dynamics of any other country. We still have devices which are 6-year-old running on Android 5 or Android 6. And we have Android 14 or 15 coming out latest, right? Like there's so much of variance over here that some of these technologies, it becomes difficult, right? We were discussing earlier that you have to keep support for both, but there is a cost involved when you have to keep support for both, right? The latest and the prior generation of, like, if you have to support this advanced, you have to also support for backward compatibility. And sometimes it becomes so complex and difficult, adds to complexity at such a scale that you're like, well, let's stick to the basics and not get into the fancy latest technology because that works.
Yeah, I mean, we have experimented with a bunch of things. I mean, I remember trying out EMBMS, right, which was, I think in 2019, we tried that, right, which is multicast over, mobile networks on 4G. And that was 2019 at the very beginning. 5 years ago now.
But at that time,
6 years
it was
ago.
like a game changer.
Yeah, it was supposed to be that next big game changer. But that had one significant problem, which was that the time for that client or the player to train onto that stream was like a minute. So it became a impossible thing to take to market.
This is broadcast over a 4G. Well,
Yeah, I was also a fan of the MBMS or LTE broadcast. I've always wondered, and I thought India was going to be the place where it worked because you have the largest 5G network and you have the largest live sporting events. So the two should really match very nicely.
Yeah, so that was the key challenge. So we always look forward to these new possibilities, but it takes a long while for that to be available at scale.
For all the constraints that you and Ashu mentioned, there's one that I probably will pick your brain on, which is you were leading a project for LLSNS some time ago. You did a lot of that testing. A lot of these constraints, we've spoken offline, came up with that project too. Is there merit for you to invest in those kind of projects, or are there reasons enough for you to not go into that for some time?
Yeah, I think it finally comes down to what's that market, what's the effort, and what will it cost to do this, right? Like I said, we maintain, just for the two codec families, we maintain a whole completely redundant set of infrastructure to stream both, while adoption is building up on the more recent one, the more efficient one. It's the same argument. Now, if you want to do LHLS, we know that today that coverage of that particular protocol is only for a very small set of devices which can consume it on a very specific type of network environment, right? Mobile is out. It won't work over there at all. We have tested this, through months of testing in multiple environments. Where it did work consistently was only on a very narrow slice of one particular device on one type of network, which was very consistent. But as soon as you took it to the same device in a mobile scenario or a mobile scenario, it didn't work. So if we cannot have a sustainable stream for 4 hours, we're not going to deploy it. So that's the reality of it right now. So we can run it for small groups of users on the floor within our campus, but taking it to market is still some time away. But we'll keep experimenting. It's not to say that we won't do it. Right?
I think it's all the function of unit economics, right? Like, yes, there are users who would like to have these top-notch technologies, latest experiences, and all of those. But does it make sense as a platform, right? I think this is something we're going to chat about in the next segment, which is basically how do we monetize? And I think we will cover a lot of things over there, that how some of these choices are function of that, right? I think even from an infrastructure perspective, to be able to support all technologies and all variants of it is not easy. I'm not sure what you and will think about that, but in my opinion, as an infrastructure company also, it will be hard for you to also think. And as for us, it's the same thing applies for us also, right? When we are planning, we have to think about the cost and everything involved and what value and ROIs it is giving.
Yeah. I mean, there's one thing which kind of came as a good outcome last year for something completely new, which was that as much as 10% of our concurrency on a big game is actually watching on a completely different protocol, which is faster than the lowest latency, newer protocols as well. And that's a big achievement. That's helps us give a differentiated experience to that set of users. But it's a very, very narrow slice. It's a very narrow bridge. One certain type of device, one certain type of network, that environment can consistently deliver that. But yeah, finding more such slices and wider ones is important.
Makes sense. I think that pretty much concludes this episode. Thank you, gentlemen, for your valuable insights. For all the viewers connected to this video, thank you, and look forward to having you in the next episode. Goodbye.